Okay, let's take a look at the third type of fractions that we can use partial fraction decomposition on. And this is an example of one, 3x minus 5 on the top, x cubed minus 1 on the bottom. And remember that it's always whatever is on the bottom that's going to determine what the pattern is that we're going to follow. So the first thing we have to do is factor and see if it breaks down and what it breaks down into. So the numerator is 3x minus 5. X cubed minus 1 is called the difference of cubes. And you may have learned that when you were factoring at some point, but it's a nice little pattern that you can follow. And so I'm going to write the pattern over here because some of the problems in this section use the difference of cubes and the sum of cubes. Notice that it's x cubed, and 1 can be, the cube root of 1 is 1, so 1 is a cube. Another one you could have it be like x cubed minus 8. 8's a cube of the cube of 2. So a number that is a cube. Okay, so this is the sum or difference of cubes. And so we have a cubed plus b cubed. That's the sum of two cubes. The pattern's going to be a plus b times a squared minus ab plus b squared. Okay, and the difference of cubes is a cubed minus b cubed, which is what we have here. And the pattern is a minus b times a squared plus ab plus b squared. You don't need to memorize those patterns. Just realize that they exist and that you can look them up. You can even just Google sum of cubes, difference of cubes, and that pattern will pop up for you. So this is the way to factor the sum or difference of cubes, okay? So for our example, we have the two cubes. So in other words, a is equal to x and b is equal to 1, okay? So our factoring would be x minus 1 times x squared plus x, just x times 1, plus 1, because that's 1 squared. Okay, so now let's get into partial fraction decomposition. So notice that x minus 1 is that non-repeated linear factor, right? So this denominator is going to have like an a over it, okay? This other denominator here, x squared plus x plus 1, notice it's not factorable, okay? Because if we tried to factor, we would have to have 1 and 1, but that would add to 2. We could never get 1 in the middle. So I'm going to write that, not factorable. That's going to matter a little bit. Okay, not factorable. So case 3 happens when we have the denominator has a non-repeated, so it only happens one time, that x squared plus x plus 1 has a non-repeated, irreducible, quadratic factor. Lots of big words there. I wrote down the definition to make sure I have every word correct myself. So the denominator has, so non-repeated, so it just happens the one time. And it's irreducible, so in other words, not factorable. We can't reduce it any further. It is quadratic factor. Okay, so the pattern that we're going to use for that, we're going to write out, we have 3x minus 5 over x cubed minus 1, and we're going to break that into different fractions. So our first one is the x minus 1, that's the linear factor there, and that's an a on the top. The second one is just the other denominator, x squared plus x plus 1. But instead of just having a b, because the denominator is a quadratic, we now have a little pattern to follow. It's going to be bx plus c. Okay, so that's the pattern for type 3. The numerator will, instead of just being a single constant, a number, it will be a linear factor. Okay, so bx plus c. If we just had the 1, it could be like ax plus b. We just need to find out these two numbers. We'll have a coefficient of x and we'll have a constant term. Okay, so that's the pattern that we have to follow for these. Now let's solve this problem. Now, the good news is all 4 cases really are solved the same way, just as long as we know what that pattern is that they follow. So the first thing we always do is multiply by the denominator, right? Now the denominator, you can write it as x cubed minus 1, or you can write it in the factored form, whichever one you want. So I'm going to write it in the factored form just so I can see exactly what will reduce out for each term a little easier, but remember that equals x cubed minus 1. So on the left we'll just have 3x minus 5. On the right we'll have a times x squared plus x plus 1. Okay, then we'll have, better use a parentheses there because the whole numerator is bx plus c. That all needs to be multiplied by, oh good, the quadratic cancels out, doesn't it? So we just have to multiply it by the x minus 1 factor. Okay, so now this is the problem that we're trying to solve to find a, b, and c. Okay, so what I like to do, if I possibly can, is use a smart number and see if I can't find A, B, or C, right? So in other words, the technique is let x equal some number so that I can solve for one of the variables. I think that method, that's the second method I showed you, but I think it's just the easier method. It simplifies the problem. The other possibility is I would need to multiply everything through, collect the terms, and then make a system of equations by comparing the left side of the equation and the right side of the equation, okay? So let's start by, let's see. I think the easiest thing to make x equal would be 1. Because see, then bx plus c is multiplied by 0. So that's great because that whole thing will be gone and I bet I can find a. So let's let x equal 1. I think that's the smart place to start. So that's 3 times 1 minus 5 equals a times, that's 1 squared, I'll just write it out I guess, plus 1 plus 1. And then that's plus b times 1 plus c. But that is multiplied by 0. 1 minus 1, 0. So this whole term is 0, okay? So 3 minus 1 is negative 2, and that's a times 1 plus 1 plus 1, 3, okay? So a is equal to negative 2/3. Okay, well that's good news because I did figure out what a could be. Right? Now let's see if I can use that technique again because, again, I think that's the easier technique if I can just figure out something else. So I'm wondering if I could, see now that I know a, I could set x equal to 0. See, it wouldn't have worked before because I would have still had an a there because it's it would be a times 1 if x was 0. But now that I know the number of a, I can just put in negative 2/3, and I can put 0 times b. The c will still be, multiplied by 0, but it's actually multiplied by 0 minus 1, so it's actually negative c. So that's going to work. Okay, let's let x equal 0. Okay, so that's 3 times 0 minus 5 on the left, and then a is negative 2/3. And then remember, I kind of sometimes highlight this equation or box it because I need to keep going back to that equation, okay? So I'm still using this equation. So when I put in 0, that's 0, 0, and 1. So that's just negative 2/3 times 1. And then plus, well, that's going to be b times 0 plus c times 0 minus 1, so negative 1. Okay, let's see if I can't get a little bit more space here. hoping I'm, close to finished really with the problem. So that is -5 here, -2/3, and then that's 0, so just minus c, okay, or c times -1. So now I have to add 2/3 over here. I think I did that. I just, yeah, it's like, I did it by hand. You can use a calculator if you want. I made this -15/3, added 2/3 to that, so I got -13/3 equals -c. So c, I know, is 13/3. These numbers are not convenient now, but they're still not that bad, and you don't have to use them all that much once you solve for them. Okay, now we still have to find b, but if we have all the other variables, remember, at that point, we can plug in really anything else for x, and we'll find b because we only have one unknown. So what I did was plug in 2. So let's do that. So I've already worked out all the fractions for you. Oh, see, I need that equation. That's the equation that I need. And let's go back and let's say, oh, technical difficulties. Ah, geez. Let x equal 2. So that's 3 times 2 minus 5 equals, a is -2/3. And then we have, I'm just going to do this in my head and write down the final answer so I don't have a million steps. So I'm putting in 2. So 2 squared is 4, plus another 2, that's 6, plus 1, 7, okay? And then that's plus b times 2 plus 13/3, and then that's times 2 minus 1, so that's just times 1. Okay, so let's see, that's 6 minus 5, so that's 1 on the left. -2/3 times 7 is -14/3, plus, now this is just times 1, so this is 2b plus 13/3. Okay, feel free to use a calculator for these things, just use the divide and combine your fractions. It doesn't matter if you're not super comfortable with the fractions and all. Okay, so I multiplied, let's see, this is -14/3 plus 13/3. So I combine those, so this is 1 equals -1/3 plus 2b. Then I added a third to the other side, so that's 4/3 equals 2b. So b is equal to, I have to divide by 2, so that's 4/6, or 2/3. Okay, so b is 2/3. So yay, we're finished. We just have to substitute all of these numbers back into the fractions that we created, right? So remember, the bottom of the fraction, the first one was x minus 1. Wait, I want to go back and review just to make sure I'm not messing that up. Hold on. Yeah, a over x minus, sorry. I hope I didn't make you seasick. A over x minus 1 plus bx plus c over the quadratic. Okay, so a was -2/3. So -2/3 over x minus 1. Do not simplify more than that. Don't think like you have to do something with the fraction in the fraction. Thank goodness, no. Plus bx, now b I just figured out was 2/3 x, and then plus c, so plus 13/3, and that is over x squared plus x plus 1. And that is how we decompose that fraction.